Hi, my name is Artem and I work as a senior DevOps engineer at GlobalDots. My focus has always been around building cloud, on-premise, or hybrid environments with infrastructure as code principles in mind and security behind the scenes. I love containers, Kubernetes, and the whole cloud-native ecosystem that has been growing tremendously over the last few years. I've been in IT for 12 years, and I think today is the most exciting time letting you to choose among a variety of tools and technologies to learn, and I have never stopped learning. That is so great. And today I'm going to speak about implementing GitOps approach on my recent project, and I hope you will have fun watching it. GlobalDots represent a team of top-notch IT experts who strive to deliver excellence in such areas as web security, cloud management, DevOps, and AI/ML. What's important is that we continuously search for cutting-edge technologies to improve our practices, bring in innovation, and deliver success to our customers. Therefore, we are proud to state trusted partnership with over 400 global businesses, and this number continues to grow. So I'm going to provide some intro about GitOps in general, what this is and what is implied by this term. Then we will see how Flux uses GitOps approach and what it provides. Then we'll talk about structure, about deployments, maintenance of in case of such approach. We will talk about some drawbacks that are there no matter what. We'll also touch such aspects as tests and validation of the structures and some closing stuff like future plans and some thoughts. So I hope we're going to have fun, although a couple of disclaimers. So I'm not going to touch base on the battle between Flux CD and Argo CD. These tools are often compared together, and you can find numerous discussions of that on the web. So I'm not an expert in Argo CD, so I'm going to talk strictly about Flux. And also, of course, this presentation contains a lot of CLI usage and YAML, which is not going to make it very fun, but a regular DevOps engineer shouldn't feel bad about it, so to say. So let's begin. The GitOps. GitOps as a term, as a notion, appeared somewhere around 2017 when engineers and cloud native evangelists all over the world started to feel that it is a very fitting approach when you deal with Kubernetes infrastructures, with cloud native technologies, and this has become popular and has been adopted among a lot of projects over the last 5 years, I think. And if we can summarize GitOps, well, we can say that first of all, it's an operating model that provides best practices to put infrastructure as code on a Git repository, manage it, monitor it, and well, mostly it's not necessary, but mostly it is used in case of containerized clusters and applications. So when we talk about GitOps, 99% of the time we are going to see containers getting managed by a Git repository. And also, as a second main aspect, it's a path towards developer experience for managing applications and their configurations, because we get besides the configuration of apps themselves, we also include CI/CD pipelines here, Git workflows that are meant to validate the changes done to the infrastructures, to have some kind of gates that these operations pass before getting to the target infra. And there is also a nice and brief GitOps pamphlet on this resource, GitOps.tech, where you can also read a summary of this approach. So if we look at the scheme, so it's pretty simple. First of all, we store infrastructure, configuration, application as a code on a Git repository. It's always the source of truth, and any changes done to the Git repository to its default main branch normally undergo CI/CD pipelines. Those are checks, validations, some tests, and finally committing approval and deployment to the environment it is meant to be in finally. So that's it. This flow is pretty straightforward. What GitOps tools add in addition, Flux CD as an example, we also, well, this model is kind of fire and forget way, and GitOps tools also add reconciliation loop. That means that the target infra is always synchronized against the state of the repository, which makes it even more robust, even more actual, and forbidding any manual actions done with engineers' hands directly on the clusters. So based on my own experience, I've been working with GitOps over the last 3 years. I can say that the main benefits are that you can read your infrastructure like a book on a Git repository when every component of the infrastructure is declared somewhere in a form of code, well, mostly configuration code, which is YAML, but not necessarily. The main thing here is you can get to it. You can locate the spot that needs to be changed and apply your changes at this spot and see the effect. Audit is a very important thing in providing resilience of the infrastructure. So the Git-based approach provides Git capabilities in the form of pull request review, in the form of approval of these pull requests, or validating, running automated checks, etc. And recovery. So in general, Git revert, simple Git revert, which is a very fast and like an action which doesn't require a lot of effort from you, becomes the means to do rollbacks of the changes in the infra that can be actually very large, that can affect multiple servers. But a simple Git revert may put your infrastructure into the state that was before the changes. Of course, we should mention that there could be data mutations inside the changes, and in this case, this is not going to be possible, not always possible, because data mutations may have a rollback and all may not have it. So this one should be very careful about it. But speaking in general, this is a great benefit. And drawbacks from the GitOps approach, from my experience, implicity, so that all the actions that are done after you commit changes to the repository are done somewhere behind the scenes. It's always asynchronous. You can only observe the results, watch what's happening, and check logs and etc. But you cannot, you don't have control over what is happening. You don't use any commands, any tools that you are used to when you like manage traditional environments. Complexity, it's not a one-for-all solution. You cannot just apply some GitOps structure on your project and expect it to be successful. That's not going to happen. So every particular project, application, or family of applications needs to be assessed, needs some consideration to make the structure optimal. So this is always going to be some initial design of the structure. So that's it. Let's move to Flux. Flux is a tool set or a family of tools that enables GitOps for Kubernetes-based environments. Right now, nothing except Kubernetes is supported, but as we all know, Kubernetes is basically 90% of what's there in the wilds currently. So we're going to talk about it. So Flux CD is composed of a GitOps toolkit, which means that the cluster runs controllers that do all the work, and they are a set of controllers completely separate from each other and doing each doing its own thing, its own task. Flux has extensions, some functionality that can improve your experience. It has integrations into well, you can integrate it into your CI/CD systems. You can integrate it into your monitoring and so on. Security level is pretty high, and Flux team has done a good work aligning with all the compliance standards. So it's like you take it, you put it to your cluster, and you don't worry about passing or failing any benchmarks. Monitoring is included out of the box, so Flux supports Prometheus metrics. It exposes them, and also it provides some alerting and dashboards and all that stuff. Also, there is a question mark on the UI point because well, it doesn't exist by default. There is work getting done on making it happen, but traditionally and as the project evolved, this Flux has been positioned as a strictly command line based toolset. So a bit of a brief look on the architecture. We can see that there are, as I said, controllers running in the cluster. So source controller is the portion that gets different kinds of sources. This can be Git repositories. All modern kinds of providers is supported. You can go as a generic Git. You can go into specific GitHub, GitLab, Bitbucket configurations, or you can also, well, source controller also is responsible for Helm sources like Helm charts, Helm repositories, and it can pull them from S3 buckets as well. Customized controller is probably the most root element that processes and handles, first of all, raw Kubernetes YAML manifests, and you can also pass a customized structured application or a set of resources to customize controller, and it will work with it natively without any issues. And Helm controller, Helm is handled, well, we can say almost natively. Flux provides its own resource kind to define how to deploy Helm charts, but after it does its job, Helm controller, after Helm controller handles Helm installation, it's actually you cannot differentiate it from a chart that you would deploy manually with Helm command. So let's try to start with a bootstrap procedure. This is going to be a first demo. I'm going to show several small demos to make you to get some feeling of how it looks like to manage a cluster with Helm. So first of all, I start with the Minikube cluster. I prepared it. It's a freshly deployed. You have a single node. You have basically nothing. Basically, here here's what we get when we deploy it from scratch, and I'm going to run a Flux bootstrap command. So here, what we see, we are using GitHub Git provider. We pass the own repository branch. It's going to be main branch, and the path on the repository that contains like the entry point allocation, or where we should start searching for everything that should be contained in the cluster. Also, I authorize by a token, I'm going to provide it, and I add toleration keys, just in case in this particular case, I want Flux to be located on the control plane node. And just to show you the repository itself, so in the root of the repository, we can see the structure like a separate location for apps defined here. There is a couple of apps included for Helm charts, also a couple of Helm charts that are stored here. Infra location is everything related to infrastructure applications. And finally, clusters. Well, we can have multiple clusters here. I have a single demo 000, which then inside itself, it almost repeats the structure we have on the repo root, but it's going to inherit the elements from the upper location and apply some cluster specific things. So there is a brief explanation of the structure, not going too deep right now. Let's first of all, let's bootstrap. So I'm going to provide the token here. So what we see, we connect to GitHub, we pull the main branch, cloning it, see what we have in the cluster right now, generating manifests, reconciling, and basically after this action is done, we are going to see that Flux deploys its components. Yeah, we have a Flux system namespace that appeared, and we see that controllers are getting started. We can see that this bootstrap procedure has been executed. Let's see again what we have here. And well, all the components, all the 4 controllers are running. And some new elements start to appear. A bit a comment in advance that they have a dependency tree. So some resources going to appear first. Some resources will wait and appear later. Oh, here we already see much more stuff going on here. We have application namespaces. We have some more ingress, local path storage, security. So all this stuff is getting here. And with Flux toolset, main things we would like to check is customization. So customization, we can call it a group of resources, and we see that all of them are basically synced to the repository. The revision is applied. We can see the list. We can see whether it's suspended already. Basically, it's the first thing to check. So let's, from the bootstrap procedure, this is it. Minikube will take some more time to make everything work. We see some more stuff is getting up. So it's going to be a bit, it's going to take some time. So we will just resume our presentation. So to continue our conversation, let's talk about Flux core objects. First object is customization. I would say it represents a collection of cluster resources managed solely as a unit by Flux. So you can group multiple resources together, and Flux will treat it as a single reconciliation point. And when all resources are healthy, it will show you that this customization is healthy. It can contain a single application, it can contain multiple of them. It's up to you to decide how to structure it. So a customization resource, which is a custom resource of Flux, it's normally a pointer to customization.yaml file, which should exist on the path where Flux looks at, but it's not necessary. Just a comment here that if it doesn't exist, Flux will just scan recursively through all the directories and all the manifests it finds and applies everything it can find. But if it exists, if customization YAML is defined, you get the ability to define explicitly what should be deployed inside of this particular group. So let's see example of customization YAML. So it contains a list of resources. So in this example, we kind of include something from the upper level. We add network policies. We add some secret with a certificate. We can also include a subdirectory. So here it doesn't have .yaml extension. So that means it will go into a subdirectory and scan for also customization YAML file inside of it. Then there can be some Helm release defined and a patch that is getting applied over some resource that is defined, that is included already. So a patch is a way to make something specific to this particular spot where you group these resources together. Such approach makes it possible to have some generic configuration, which doesn't differ between clusters or between namespaces or whatever, and bring in something that is more specific to this location. So an important thing here is that anyone who starts to using Flux often tends to mix up two things. So actually, there is a Kubernetes native kind customization, which represents actual customization structure, customized structure, but it is not a resource that is present in the cluster. It is a way to define this customized structure. And when you have a Flux customization resource, it is going to exist inside the cluster, and it's a representation of Kubernetes native customization. So these two things are basically talking about same entity, but they're named in the same manner, and there are very wide discussions why such decision was made, and many suggestions how to name it differently, but we should take it into account. So let's take a look at customization object. So first of all, I want to take an example. For example, demo app home dev. So it's like a demo app deployed to dev environment. And one of the basic commands we can look at is to show a tree of resources. And here we see everything that is included into this customization. Basically, it starts with a namespace. Let's take a look at the namespace. So inside this cluster, namespace demo app home dev exists, and it has these labels that point to Flux customization with the name and a namespace Flux system. This is the namespace where the customization object exists in the cluster. So we put customization object into Flux system namespace, and then it rolls out all the other included things into its own namespace. Since it's a custom resource, we can also manage it with kubectl. So we are going to see exactly the same set of customizations, but with kubectl. And I also want to show you that if we describe a customization, we will see also a tree of resources, some Kubernetes elements, some events, and we can see that reconciliation finished, and the next run is going to happen in 10 minutes. So the period when such resources are reconciled is tunable. By default, it's set to 10 minutes, which is fairly frequent. Okay, if we take a look at the customization from the code side, let me show it to you. So on this repo structure, I navigate down to clusters demo0 apps, demo app home, dev environment. So this is basically the location of this customization. By the way, I define it also here. So this is the Flux customization resource, its name, its path. So exactly the path I showed you is done here. And also it has a dependency on another customization because it needs those resources to exist in the cluster beforehand. And here in dev location, we have a customization YAML. It's pretty rich here because it's actually customized structure. And what I included here, there is a namespace YAML. Namespace just defines the namespace. That's all. Ingress YAML, so some ingress resource to expose our application stored here. Here we have an inclusion of the more generic app structure. So it's going to be outside the clusters location. Let's move here. So by this line, we include everything defined in this customization. Okay, so we also add network policy, service account, and these are applications themselves. Some patches that are generic to the application are going to fall here. Let's take a look at base. Base is the raw skeleton of the application. So there is deployment, service, pod disruption budget, horizontal pod autoscaler, and service monitor. So everything you can think of when you think of an application, like command labels, some very generic configs. And when we talk about like specific applications, they inherit this base skeleton and also add some specifics like suffix, also labels, configuration items, some patches, for example, resource requirements, some naming mutations, etc., etc. So this is all included by this line. And in addition to that, we provide the particular image version through images directive. We do some environment-specific configuration here. So some URLs are provided, some timeout, etc., etc. What is specific to this dev environment? So these settings can be different end to end. And also a way to apply patches. For example, for dev environment, I don't restrict resources, so those are removed. I add tolerations that put the application to a particular node group, and add some shared common environment variable that tells me that I'm on the dev environment. So all of this is the structure that helps to make the deployment of the application formatted in a dry manner and very efficient. So let's get back to the presentation. Okay, let's move on to Helm release objects. As I told you, it's just a meta object that defines how to install a Helm release, from which repository and which values to provide to it. There are multiple ways. Well, with Helm, the most important thing is values, of course, and Flux CD provides several ways to define those values. So they can be explicit in the manifest of Helm release as YAML. They can be pulled from file. And this file can be located on different levels and layers. We can also include values from cluster config map as secret. And in theory, this makes it possible to like have a generic set of values. And when this Helm release with generic values is applied to the cluster, the cluster has its own cluster-specific variables stored in a config map or secret, and they are getting overlaid with the default set. And well, this object is watched by Helm controller and getting applied to cluster. So defining chart source is done in a specific manner. With Flux, you define chart sources separately, and then you refer to them. Release name, target namespace, I think it's clear, values. A small drawback exists, and I always warn about it, that Flux and Helm controller, they manage Helm release object. And that means that it cannot understand the changes that are done to the objects that Helm manages it on its own. So for example, if you deploy, I don't know, Postgres Helm chart, then the Helm chart deploys a stateful set, and you want to modify the stateful set manually and set some configuration. Flux will not detect that a Helm managed object was changed. It will not revert these changes syncing with the wrapper, because Flux syncs the values that are kept in the Helm release. It doesn't sync the values that are getting eventually rendered from the Helm release. It's like a thing that you should be aware of, you should understand, and basically the normal cluster operations, they shouldn't include any manual actions done to the cluster. This GitOps approach actually just forbids it, maybe with the exception of some debugging and troubleshooting, but there are always ways to like revert to reconciliation. And actually, with a combination of commands Flux suspend and Flux resume, like suspending reconciliation and resuming it, you can synchronize everything back with the repository. And also there is a GitHub issue where this particular drawback is discussed, and Flux team are going to prepare a way to reconcile Helm releases, including Helm managed resources. They have been working for a long time on it, but I think they are close to covering this point too. So let's take a look at Helm release objects. I will show you basically how they are defined per se. For example, here is my definition of Ingress Nginx. I have this source here. I have all, well, I tend to put the URL to all the values definitions here, and I deploy it as a daemon set. I enable some root mode, host port, ingress class by name. All these values are from the chart. Also, I add an extra init container to apply some tunings and bring in some tolerations and node selectors. So everything is defined here statically and explicitly, and it's like convenient for me to look for a particular spot on the Git repository, so I know that it is an infrastructure component, that it is belongs to Ingress resource group, and I find it here, and if I need to modify it, I do it here. So let's do one more thing. Let's like add a Helm release object to our, for example, dev environment. So to do that, I will add a YAML file. Let me edit, and I have the definition prepared. Hold on, I have it here. Sorry, it shouldn't be MySQL, it should be Redis, because I prepared the Redis deployment. So Helm release Redis from Bitnami repository, a range of versions. I'll talk about it later. So some specific configuration of Helm release object. So there is an interval of the reconciliation of how often a Helm release is going to be synced. there is a timeout for installation or upgrade operations. Also, there are like a limit of remediation attempts. So when installation fails, it's going to be to retry 3 times before it says it cannot do that. Same for upgrades. And but a couple of values I add here, I make it standalone architecture and so on. So basically, I added the resource itself. I added it to the list inside customization YAML. I'm going to make a git commit of these 2 files and say add Redis to demo app home dev environment. Okay, we make a commit and we push it to the repository. As soon as I push it, it's going to take the period of reconciliation of customized controller, which is 10 minutes by default, to pull these repository changes and apply them on the actual cluster. Flux toolset actually gives you the possibility to force this process by Flux reconcile command. We can reconcile customization, demo app home dev. Okay, so we will do that. Actually, hold on. You would want to say with source because you want to synchronize the Git repository first and then synchronize the application customization. And this key allows that to simultaneously and do not run 2 commands. So inside demo app home dev namespace, now I have a Redis pod. You see, was installed 4 seconds ago, so pretty fast. Everything was reconciled. Okay, Redis is ready. One more thing I'd like to show you is how to manage Helm charts of our own. So let's navigate to my repository to charts, and let me show you my custom defined chart. It's called default namespace network policies, and it's something I templated for my clusters. It includes like default policies that should exist in every namespace, and I defined values like incoming cluster traffic, outgoing cluster traffic, private traffic, monitoring traffic, API server, internet, all of this. And it's convenient for me to deploy this chart multiple times into multiple namespaces. For example, here I have the definition of security namespace, and I define all these values, which can be different depending on the purpose of the namespace. So here I have some trues, some falses, and for example, let me show you one specific point I have here. Okay, for our demo app, I also define network policies for the namespace itself that is getting bundled with the application. Those are more restrictive, and here when I went with the reference of the chart origin, I actually provide Git repository, not a Helm repository, and for our Git repository, I put the path where the chart is located. And basically, apart from that, all the rest of the mechanics with Helm release is done through values. And this is getting applied to cluster. So, for example, we can see Helm release into all namespaces. We can see that default namespace network policies chart is deployed into each namespace that exists here. Okay. So the point is that having some resources deployed into multiple namespaces and more or less just with a couple of configuration changes, the most convenient way to do that is to define our own Helm chart and use it across all namespaces. Let's talk about the structure. How we can put what we have onto our repositories. So Flux documentation suggests the basic structures to start from. So the most common approach is to store applications, infrastructure components, and clusters all in separate groups. Application can be split into environments. Infrastructure can be split into environments, as well as each particular cluster can have its own tree of resources. Also, there can be a multi-tenant approach where you also add teams, and teams on their side contain some structure of applications. But I tried to start from the basic approach, and soon I felt the need to form more granular resource groups, because when you bundle all infrastructure components into a single customization, into a single group, you at some point you start to experience the dependencies of different resources, or a failure of a single resource can halt the whole group, and it can bring speed downs, which is not desired. Same stuff about applications and the environments. So I came up with the structure that puts each environment, dev, stage, prod, into its own resource group, so they are not somehow interdependent. So this is the structure I showed already, and we have apps defined, we have infra defined, and inside the infra, I also have all these buckets of resources. And between these buckets, we can also bring in some dependencies. So one group can be installed first, or another group is dependent on it and installed in a second row. Also, it's possible to bring in dependencies between particular Helm releases. That is also a feature of Flux. And all those buckets are formed somehow like this. So ingress, everything related to traffic, incoming to the cluster, observability stack, storage is in case we have some storage managed by cluster, security elements like policy engines, like runtime, threat detection, and operations group. Here I put some cluster add-ons which help in day-to-day operations. Yeah, that's it for the structure. I think we can get to deployment now. So I showed you the structure of an application that is defined in a customized manner. And when we talk about deployments and application updates, we can talk about two different things. So one thing is to update the code of application, which is normally an action of version update. So a single image version update makes the application pull the most recent changes. And we can also have the updates to the structure of deployments, to the resources and environment variables and so on. Both of these are managed through Git commits, and for application updates that bump the version up, I use CI pipelines, and for the structural changes, that is usually an ad hoc job when you do Git commits manually. So here we have the image definition for a particular application, and it's going to be a Git update. So let me switch to my demo app and go here. In this tree of resources for the demo, I use Nginx unprivileged container image. And basically, I'm going to bump the version here. Okay, for the dev environment, again, this is what I'm going to do manually now. And basically the same set of operation is wrapped into CI pipelines, because it's just 3 or 4 commands for making a git commit. Okay, let's push and let's watch what's going to happen. Here we are watching, and here reconcile as K8s as a short for customization. Demo app home dev. Yep. Oh, okay. It's actually I was too slow. Actually, it's already done doing the reconciliation. So we can see the applications are getting rolled over. A new version is getting up, and then old versions are getting terminated. And this way, the application got updated. So here we got all the version updated to 1.23. And in the repo, we have the commit that does this. So it's tracking the history of changes. Also, we can check that from the log side, everything is just fine. Okay, actually, it's no errors are here. There is some actions about Helm releases, but in general, things are looking fine. So here's a snippet of how the deployment looks from the GitHub Actions side. Install Flux, check out the repo, update application version, check deployment status. I do it like with the watch command, so that it verifies that the deployment has been finally successful. kubectl allows that. And if there is a failure, there is a Slack notification about the failure, and all the changes are reverted. So everything is going to be automatic. Now let's also touch base on some maintenance aspects. So first of all, and a very nice thing that Flux provides with Helm releases is that there is a way to define a range of versions within which the application deployed is going to be updated automatically. So, for example, in this definition file called Helm chart is installed basically from version from the minimum version that fits into this range. And when any update to the version is getting pushed to Helm repository, Flux will automatically pull it and apply it. And well, I would normally define the range within a particular major version, because we know changes between major versions can have backward incompatibilities, and you should treat it manually. But minor and patch versions are kind of okay to apply automatically. I don't experience issues with this approach. So all this burden of updating infra elements is becoming automatic unless you want to perform a major upgrade. Slack alerts are conveniently done for any reconciliation failures. So if there is something that prevents successful sync, you will see an alert. You can tune the period of checking, how long this reconciliation fails, and so on. And basically reacting to these alerts means getting to troubleshoot why Flux fails to do its job. There is a nice Grafana dashboard. It contains generic details about how many reconciliations are happening, with which speed, how you can also have a graph of the differences in speed at different points in time. There will also get a separate dashboard provided for Flux controllers themselves, how effectively they operate, and so on. And also Flux provides a very rich tool set, which I personally like very much. So for this, I will just show you that first of all, Flux logs command, it can filter by namespace. We can, for example, check how observability namespace feels and what is happening there. We can also say that we want the logs. We want the logs since 15 minutes, for example, and we'll make it shorter. Also, we can tail the logs in real time, and we can just run some action, some reconciliation, and see what's happening. So here, for example, we see the error. There is a timeout waiting for condition. We can get to the Helm release of Kubernetes stack. Well, yeah, some timeout occurred on my Minikube cluster. That may happen. And to check for a more detailed error, I'm going to check the Helm release resource. Shortcut is HR inside observability namespace for Kubernetes stack. And here I have the events. There is a Helm logs. Persistent volume claim is not bound. Deployment is not ready. So Grafana failed to deploy. There is some issue with persistent volume, which may happen when you are working on a dummy cluster. That's fine. Then also Flux reconcile, suspend, resume. All those things I showed already. Suspend, resume just means that you are stopping reconciliation for the time being when you want to do some investigation, and then you just resume and bring everything back to its order. And two more commands, flux trace, flux diff. Okay, let's see what they can do. Flux trace, you can check any resource in the cluster. For example, let's see what we have. So we have, for example, an ingress here. We can say flux trace ingress demo app hope movie. Hold on. Trace resource and name. Let's try to do it on namespace. Okay, yeah. For namespace, we see that this is object managed by Flux. It belongs to a particular customization. There is a path. There is the last commit and the Git repository where it is stored. You may find yourself in a situation when you have multiple Git repositories included into Flux reconciliation, because you can make the structure very modular and separated by multiple repos, and Flux trace makes it possible to draw the path, the origin path where this object came from. I wonder why Flux trace ingress didn't work. So maybe I need to indicate the namespace. Yeah, I added namespace, and now Flux can show me that this object stored here, taken from here. That's it. And Flux diff is meant to show you what is going to be different when you, for for example, had multiple changes, it does a server-side dry run on resources and prints the diff. So it actually contacts the cluster, tries to apply the changes as they are seen by the cluster itself, and show it to you. So Flux let me do some changes here. For example, let's change the timeout value that is stored here. Then this is a very basic example, of course. I think you won't necessarily do it for very small amount of changes. It's interesting when you when you bundle a lot of changes together. So customization, you need to provide the customization name, demo app home dev, and here you provide the path like this. Div customization, security path customization, Flux get customization, demo app home dev, and path. So it used to work before, now it doesn't. I may be overlooking some error. Let's just move on. So Flux diff may be useful when you track the changes of what you are going to commit. So getting to the bad points, weak points about Flux. There is no native UI because the team of Flux are CLI fans, and there is a side project from Weaveworks. Weaveworks team, they develop it separately from Flux team. It's going to happen soon, but they are working on a whole big ecosystem, big GitOps platform that is going to have both Flux CD tool set up behind the scenes, the UI, and some more deeper integration into all the GitOps operations. So it will be a whole platform where you just which you use just doing some clicks around, and it's meant to simplify the life of developers. There are no or very rare integrations to CI/CD systems, so there are no like out-of-the-box actions on GitHub that you can use to deal with Flux. There is an integration with Azure, existing one, where you can use Azure Portal to manage Flux. But still, a lot of things should be done by hands now. I don't think it's a big drawback because it gives you the possibility to build a workflow which you want and which is applicable to your project. But of course, there is a lot of things around it, like error reporting, rollbacks, and all that stuff is better be done natively than manually. And also disaster recovery is very complicated. I had experience of growing the structure naturally as my cluster evolved, and then I tried to perform the full redeployment, not redeployment, but bootstrapping a new cluster from scratch with the same set of components. And the main issue is that a lot of resources you put on the repository, they are declared as CRDs, and those CRDs should exist in the cluster before they are applied. If they don't exist beforehand, you're going to face an error, and basically all the reconciliation may just get stalled. The basic solution I applied is to move all important core CRDs that other resources depend on into a separate resource group. So it looks like this. I put monitoring CRDs here, cert manager, because I have a lot of certificates defined on the web, and sealed secrets for putting secrets, because secrets are used extensively across all my resources. And so these CRDs are first put to cluster in raw form. You see, I just put links here as they are stored on the repos. You should probably care about the versions provided here, but it's like one way or another. Either you care about it and put explicitly on the repo, or you face problems during disaster recovery. So it should just be kept in mind. Okay, let's talk about testing and validating Flux. I'm going to describe the three suggested workflows that Flux help to set up, because they provide several templates and scripts to do it. So first of all, linting and validating is done by means of validate.sh script that includes validating YAML syntax by YQ, Kubernetes object by kubeconform, a popular tool to do that, and also validating customized structures. And this script includes exact version and exact arguments, which Flux controller uses under the hood. So it is important, because if you just use raw customized tool, it will be different from what is actually applied. Then the second workflow that is possible to do is to dry run against the real target cluster. Dry run with the help of kubectl apply dry run. So basically here we just for all the groups we have, for all the customizations we define on the repo, or we can first customize build this set of manifests. The customize build command just renders everything in its structure and prints out the raw YAML as they are getting applied by kubectl. And such dry run helps to detect issues before they are getting merged to the main branch. And also it is suggested that a full E2E test cycle can be created with a test cluster done by Kubernetes in Docker, bootstrapping Flux there, verifying all reconciliation, dumping logs, and tearing down the cluster. Well, I did set up such a pipeline on my own. Of course, I can say that it is expensive in terms of CI minutes. If there is a limitation on that point, you won't run this workflow automatically on each push, but this is the most the widest test that will cover all the flow from beginning to end and see if the changes provide any issues. Well, in real world, when you manage a cluster, most often you just do some small changes, some configuration parameters changed, and so on and so on. But it's not going to be very dangerous. But when you like prepare a big set of changes that also change the structure, a lot of applications are added, it is good to run such pipeline manually and see how it goes and see how all this stuff works together. Okay, future plans of the project. First of all, what I want to mention is that they work on a Terraform controller. It is an interesting addition to the family because, well, it actually brings you out of Kubernetes cluster itself. So it's only the controllers that is going to be run there, and actually treat a Terraform repository and manage all the resources that you define with Terraform infrastructure as code. That that is a field that that is an area that a lot of different tools, where a lot of different tools are appearing right now. And this is going to be an analog of what already exists, but there is, I think, no single winner at the moment. So they're just entering the competition, and you see it's under active development and going to be, well, as they plan, it's going to be stable only in Q2 of 2023. So time will show if this is a very mature solution and widely adopted, or it's just another add-on that that it can be convenient for those who already use Flux, and just to add Terraform, managing Terraform configurations to the structure. And this is what I talked about with GitOps, fully packed GitOps platform. So it's a big project that is appearing. So here that UI that is going to provide some like graphs of groups of resources. A lot of things going to be managed by UI. A lot of things will still appear as command line. But as they say, so we run with GitOps to get application operations, automate deployment pipelines, everything I showed you already, platforms, so that you actually provide all this management as a single tool unit to different development teams and ease the operations for them. And so some extensions that are going to happen there. So, and today the defaults are Flux Customized Helm, SOPs, that is a secret management tool, and Kubernetes Cluster API. This helps to deploy various clusters on demand. So as you probably observed, there are some good and bad sides adopting Flux CD tool. I personally like it a lot. I started using Flux CD on version 1, which is quite different, and now it's version 2, and I used both, and I really like the simplicity of what purpose it is built for, and what it provides, what basic actions it provides. So it does the job of syncing the repository with the cluster perfectly well, because I haven't ever faced any particular issue with the reconciliation process itself. All applications I run in the cluster are constantly getting synchronized, and this is a flawless procedure. This is what I like most, the stability. But, well, you should take into account some considerations, as always, as with any tool. It solves some problems and creates some new problems. You account for it, and you just invent solutions how to deal with it. But we can say that it's a mature and robust implementation of infrastructure as code, of GitOps principles. It continues to evolve. It's adopted by a very large amount of customers. It is very mature as seen in the CNCF technology radar. And basically, there is no reason to say that you shouldn't consider it. It is actually a very good tool to start using. You can be sure that it will do its job very well. So, well, you all should make your own decision. Compare Flux CD to Argo CD if you want. Maybe more solutions will appear on the market, but the main idea of this presentation is to say that I have already walked this path. I am pretty satisfied with the capabilities Flux CD provides. It makes me a happy administrator of my Kubernetes infrastructures. And I'm pretty sure if you start using it, you will not regret it. But the decision is up to each particular project and environment and etc. So thank you all for your attention. I was very glad to share my experience, and see you next time.